Good afternoon, everyone. The webinar will start in just a few moments. The title of our presentation today is Revealed Part 1, Understanding the Full Benefits of Switching to an Alternative Non-Crystalline Silica Casting Media. Today's presentation is going to talk about various casting processes that ceramic casting media can be utilized in, along with case examples on process improvements observed by foundry users, reclamation and system upgrades, sources of crystalline silica post-conversion. Hello, my name is Shannon Carlson, together with Ray Jansen, our Industrial Sales Manager. Ray has been with CARBO for over 2 years and involved with metal casting for over 12 years. Today's webinar will be recorded. If you have any problems seeing or hearing anything, you can always play it back. And definitely submit any questions that you have through the webinar portal as we go along, and we'll have time for a few questions at the end of the presentation. Now, I'd like to turn it over to Ray.
Thank you, Shannon. As Shannon mentioned, we're starting a new Revealed series within CARBO. The idea behind this Revealed series is to help educate the foundry industry on what we've learned with ceramic media in the foundry industry. Now I'd like to start this presentation with a poll question. Shannon, if you would please. So what we're asking you is, what is your main concern with switching to ceramic casting media? The answer we've provided is some of the most common things we've heard from clients that have converted. The funny part of this is that once they've converted and they've run for a few months, they've all come back to us and said, we don't know why we fought to not do this. Knowing what we know now, we would have done this much sooner. So we look forward to hearing your responses and seeing what you have to say about that. All right, now I'm going to continue on with the presentation. I want to start out by letting everyone know kind of what foundry processes we've been working with for conversion or running cores or other suitable actions with. The main three have been no-bake, green sand, and lost foam. We do have facilities that are able to do shell coating for our material for the shell core process. And 3D printing, as everybody knows, has come on very rapidly in the past years. And we have a lot of 3D printing companies using it. In some ways, we are the preferred material for ceramic media on a lot of these 3D printers, which is great. I'm going to go over our AccuCast line of products. Now, the 3 product lines I have listed here are not all that we have to offer within our AccuCast line of products for foundry, but there are our 3 most prevalent. The other ones are very specialty niche markets, and we would love to talk to you about them if you have special needs. Low density LD products is our first one I want to discuss. Our GFN size ranges from a 10 to a 45, so we have very coarse to a medium kind of size range. We call it low density because it's actually less dense than silica at 95 pounds per cubic foot, where silica is about 100 pounds per cubic foot. Low iron means that it has a very good refractory properties. It is suitable to be used with all alloy types. However, we see it more prevalent in the lower density alloys, such as your aluminum and bronze. The next one is the ID, or the intermediate density product. It's probably our mainstay product in the industry right now. It's got a lot of different uses, works very well with a lot of different things. We offer a very wide range of GFN sizes from 15 to 80. The ID80 is the material that's used a lot in the 3D printing market. The density of the product is around 115 pounds per cubic foot, so it's about 15% more dense than silica. The iron percentage in it is roughly about 8 or 9%. We say less than 10 on here, but because of that higher iron percentage, it makes a great chromite replacement, because that iron percentage provides a great chill factor to give you that chromite type response in a casting. It is ideal for all alloy types. We've been running it for years, and we have a lot of data on all different alloys. So if you want to talk more about different things, we definitely want to talk to you. The one I'm probably the most excited about that we've added in within the last 6 months is our high temperature material, or the HT product. We added it in response to some customers' concerns. So we were approached by foundries that make very large steel castings. I'm talking 20-ton plus steel castings. Some of their concerns were that they did not feel that there was a ceramic media on the market that could handle those high temperature pouring and handle the heat load from those high temperature pours. So we worked within our R&D department and our plants to create the HT product, which has extremely impressive thermal data, and also from the testing we've done is a good replacement for their needs. Our GFN size ranges from 15 to 80, so we're using the same size ranges as we would for our ID product line. The product density is 105 pounds per cubic foot, so it's a little bit heavier than silica, but not that much, and which means we have other foundries that are looking at it just for that fact, so that we have a couple foundries that are making such big iron castings that they're kind of at the capacity of their cranes, and being at 105 pounds per cubic foot, they feel like it's close enough to silica to really consider it. The low iron of less than 3% is where we get those very high refractory properties and other things with it. We are still testing through a lot of different alloy types, but so far we have not had any issues with any alloy types. As we get further along, we'll be more than happy to update you guys. We're now going to move into no-bake. No-bake, we see a lot of great advantages with going with a ceramic media. The first one is the resin reduction. We've seen up to a 30% reduction in resin from silica. So that's a very nice cost savings to start out with. The next item that we have seen a lot of is mold wash. We see a reduction or elimination of mold wash needs with the CARBO ceramic media. Why do I say just reduction? In most cases, it eliminates it on a majority of your parts, but there are a few that you still need it because of the high complexity of the parts, or the metal type, or the surface requirements that you have on that part. So that's why we can't say it eliminates it on all your parts within your foundry. But still, it's a huge cost savings, and you'll see that in the next presentation where we talk about ROI. It improves the surface finish, we see big time, and that's with removing mold wash, we see an improvement in surface finish. And mainly that's because there's no veining defects. Veining defect is due to the thermal expansion of silica sand going from alpha to beta during that transition. There's a huge volumetric expanse which then causes the veining to occur. In ceramic materials, you have a low linear thermal expansion and you do not have that phase change. So therefore you do not have the veining defect. There also is no burn-on with the ceramics because they're designed to withstand these temperatures and not fuse. On the right, you'll see pictures of one of our customers that had converted. The left is a silica post-shakeout, so it's basically coming right out of the shakeout, and you can see how all that silica has fused to the side of the casting. On the right, you'll see a CARBO photo of that same casting made with CARBO media after shakeout. You can see how you can actually see the numbers, and there's very little material on there. And actually, if you just take your hand and rub it over where those numbers are, all that material will just fall right off. So again, there's no burn-on or burn-in with a ceramic media. The next one is reduced cleaning times. Again, if you look at that photo, you can see how your cleaning times will be drastically reduced. You don't have to grind or get off that fused silica off of there. You can just basically blast it, take a grinder, clean up the dye lines, and you're ready to go. So we see a drastically improved cleaning times, and we will show some numbers on that in the ROI calculator on next Thursday, the 19th. The next one is improved dimensional accuracy. Again, with the low linear thermal expansion, you don't have to worry about dimensional as much. You can control tighter tolerances. The last item I want to discuss is really becoming the driving force behind foundries and what GFN size they go with. Because this is an engineered material, we are able to control the sieve distributions very closely and actually have an extremely high permeability. What do I mean by that? What I mean is typically people run a 50 or 55 GFN silica sand, and that permeability when compared to our materials is closer to our ID70. In most cases, our ID70 still has a higher perm than a 50 or 55 GFN silica sand. Because of that, if you're running no bake, you can then look at going with our ID70 material, which provides you a better surface because it's a finer grain aggregate, while maintaining permeability numbers at or above where you're running for silica sand. So that means that you don't have to worry about the gas defects at that level. It also helps you with eliminating or reducing your mold wash because you're using that finer aggregate. Reclamation equipment. I want to talk to you about reclamation equipment for these different processes, and I want you all to understand this is what we've kind of seen from people that have converted. This is in no way what we feel is needed for your specific foundry. Our advisement is for you to talk with your reclamation equipment providers and go over your process in particular and understand what is really needed. Because while I'm bringing these different pieces up, it might not be well suited for your process. First off, mechanical reclamation. In no bake, it is a must. You're getting stuff that's coated with resin and kind of bonded together. You need to break up those chunks before you get into any other reclamation. Next is, do you need thermal? And as I have on here under the mechanical, if you have a good sand to metal ratio, you might not need it. Also, if you have the right mechanical equipment, you might not need it. We have a couple of clients that have a very aggressive mechanical equipment that basically kind of rub the particles of media across each other and knock off the excess resin. That allows them to not have a thermal unit installed. Again, you got to look at your process, see what you're getting, and go from there. Thermal reclamation, basically the way to find if you need it is to convert, check your LOIs and see. Or if you're running silica sand, is to run a trial with that to see how does your LOIs do over time. Because if your LOIs stay in check without having a thermal, then you don't need one. If they don't, then you're going to need a thermal, because what the thermal does is basically take the material that's coated with excess resin and completely burn that out and bring it back to like an as virgin condition. Next, you want to size your thermal unit accordingly. Basically what I mean there is you got to look at your current system. If you in your silica system are putting in, let's say, 20% new silica to kind of keep your LOIs in check, then you don't need a thermal unit that can handle all of the material going through your mixer head. You just need a thermal unit that can handle that 20% new that you're putting in. So make sure you size it correctly if you're looking at it. We can help you in those discussions if you want. We can also put you in contact with some people we've worked with reclamation companies that can help you. The different types of thermal reclamation units are gas, electric, and microwave. There are also mobile units on the market. What do I mean by mobile? There are companies out there that offer them as leasing options. So you can lease this piece of equipment. They will deliver it to your site. And in some cases, you can move it around your site and run it off of, 110 or gas or something like that. If you have interest in that, please contact us. We can put you in contact with the companies that we know that do it and help you that way. The last thing I want to talk about with no bake is reclaiming the resin system. It's one of those things that a couple years ago when we started this, we did not think about this. But the first question that we start to ask now, if you're really considering the conversion, is what is your resin system? Is it organic or is it inorganic? What does that mean? If it's organic, like a furan or a phenolic urethane, meaning it's all carbon-based, it's easy to reclaim. Basically, any thermal unit can reclaim that and get it back to a virgin state of material. If it contains inorganics, such as salts, silica, TiOS is a highly pure form of silicon that will react and form silica. We actually have a customer that we converted that was running a environmentally safe new resin system, and a couple of months in, we tested their CARBO material and found out that they had like 4% silica in their system. When we started discussing with them where it could come from, they talked to their resin supplier and looked at the reaction, and they found out that it had TiOS that even in the reaction chemistry showed that it converts to silica. So very quickly they had a discussion with their resin supplier about switching to a different resin that didn't contain that, because part of the reason for going with a ceramic media is to get away from silica. Not, you don't want to be doing something that's adding more silica in. As for the salts, what we've seen is we have people that have been running ester-cured phenolic urethane. Ester-cured phenolic urethane is primarily used to prevent veining in silica. Again, with ceramic media, you don't need something to prevent veining, as you don't have veining. The other problem with using that ester-cured phenolic urethane is that it contains a salt, usually sodium or potassium. That salt builds up over time and affects your tensils. Basically, your tensils start to drop out because you've adjusted the pH or whatever of your system. You can counteract it with reclamation if you get the right reclamation system to handle it, or you can look at different resin system. So basically, our discussion there about if you do have inorganics is you need to make sure you look at the right reclamation equipment to either get rid of it, or we need to talk about maybe doing a different resin system. Either one isn't a very good option. Now we're going to move into lost foam. Lost foam, for those you don't know, is where this all started with CARBO and ceramic media and foundry. Mercury Marine 20-some plus years ago contacted us as that they had a new parts that they had to make with very tight dimensional tolerances that they could not make with silica material anymore. So they ran trials with us and a couple other different material variants, and they decided to go with us because our material performed the best. Some other attributes beyond just that dimensional accuracy that I just spoke of are the increased productivity. Because of this being an engineered material that is round and we control the sieve distribution very closely, you have a reduced cycle times because it flows so much better and goes in and fills all those empty spaces. Also, because of it filling all those empty spaces and better supporting the styrofoam mold better, you have a decreased pattern distortion because it is held better. It also helps with casting defects. Now, the last item is the permeability. As we talked with the other and no-bake line, because the permeability is higher, you can go with a smaller aggregate and achieve the same permeability number. So like a lot of people in lost foam typically use around our GFN 40 size material to achieve permeability numbers that if they were running silica, they'd have to run down in the 20s. What that does is it allows them to support the casting better and everything and make nicer parts because you're using a smaller aggregate. Reclamation equipment for lost foam. Typically, mechanical reclamation is not needed. The only time it's needed is if you're using some kind of a resin in the material itself. There's a couple of foundries I've been in where they're making such large, intricate castings that they're actually using a little bit of phenolic urethane or furan or that in there to help bind the material up around the styrofoam as well as just packing it in. In those cases, you may need to use a mechanical reclamation to help break up the chunks. Thermal reclamation, again, is not always needed, but is usually a good thing to think about with lost foam, and that's to keep your LOIs in check. Why is that? Most of the time, your casting process can burn up all of the carbon from the styrofoam. If it's not and your LOIs are creeping up, then you need a thermal to help burn that out and keep your LOIs in check. Again, you need to size it accordingly to how big your system is and how fast you need to have new material and all those good things. Again, the main units that are out there are gas, electric, and microwave units, and there are mobile units available. I'm now going to talk about green sand. Green sand is the area in the last, I would say, year and a half where we have really made big strides. We've converted several foundries, and we have learned a lot of new information. So if you're a green sand facility and you haven't talked to us in the last year or so, it'd be a good time to have us stop in and visit and have a chat with you. First item that we see is up to a 50% reduction in clay from silica sand. And that seems like across the board. Every different operation we've looked at and processed, we see very close to a 50% reduction, which is great. That again is because we are an engineered material that is round and has, a very controlled sieve distribution. We also see up to a third reduction in water, and that I believe is coupled with the reduction in clay. Again, we see an improved surface finish. As we've seen with everything else, it's the round grains, the smaller size, all helps with the surface finish. And the fact that you don't get the fusion of what you do with the silica and that, it's a better material for castings all the way around. Reduce cleaning times was the next thing. So the big item I want to bring up there is the peel. That's the big comment we hear from everybody that's running green sand with, our material, is the peel is fantastic. Literally before with silica, they would, any part with an inside cavity, they'd have to take and, bang, do all this stuff to get the material out. With ours now, it's where you turn it over and you hit it once and everything just falls out. And it's just very impressive. It is drastically reducing their cleaning times. They're not getting, excess stuff in their blast cabinets and all that. It's really nice. Again, there's no veining because you don't have that thermal expansion as you do with the silica, and there's no burn-on. Talking about permeability, again, it's kind of the driving force behind choosing what size aggregate you go with. The reasoning is a little different than no bake in that, though. In this case, if you're starting with a material that's close to like our ID70 for size and all the other attributes, you're going to want to go with an 80 most likely, and the reasoning is because the 80, the permeability is closer. You might ask why, because again, you would think maybe more higher permeability is better if all the other material attributes line up with the 70. The problem is if you're using any volatiles, if you're using sea coal or different things to create back pressure and keep the metal in there and keep for a nice clean surface, by upping the permeability, you now need more back pressure, so you need more volatiles, and it takes time to figure that out. Once you figure it out, you can achieve the same results with like the 70 as you can the 80, but it just takes you a little bit longer to fine tune it to get there. Still, much improved surface finish over silica sand. So that's just one thing to consider when you're looking at this, is you want to really be looking at your permeability numbers for all your foundry processes, what you're running at now, and then look at the ceramic media that's closest to it. That's the most common way to look at it now. Reclamation equipment for green sand. Mechanical is a must, and it's much the same reason as with no bake. You're going to get clumps coming out the backside that you need to break down. So you need something that can kind of get them down to a manageable size before you put them through any other equipment, or you run them back through to make another mold. There are systems on the market that are mechanical that can actually take green sand and bring it back to core room sand or like new sand. There's actually a unit that there's a paper written on that is in Turkey that's doing this with silica sand and green sand. So that is something that's new to the market that's just happened in recent years. If you want to know more about that, please reach out to us and we can put you in touch with the right people to find out more about that. Thermal reclamation could maybe needed if you use a lot of cores, meaning you got to bring the green sand back to core room sand. Because if you can't find a mechanical solution that does like what I talked about before, or if it doesn't get the material back to a good enough level for you, thermal is going to be needed. Everybody that has done trials with the material using a thermal has been able to get a green sand material back to core room or almost virgin material like using a thermal. So it is the best option for that. Again, for thermal units, you got glass, electric, and microwave units available on the market. The last thing I want to talk to you about is crystalline silica in a foundry and where are all the different things that come from it. The first thing I want to do is identify what those phases are. If you read OSHA's guidelines, it is quartz and cristobalite are the two main phases that they consider to be crystalline silica. So now, understanding that, what are the areas of crystalline silica? Well, first one is molding sand, obviously, silica sand. Everyone thinks switching to just a ceramic will take care of it. In most cases it will, because even though our ceramic media show on the chemistry sheet that they have silica, that silica is bound into the other phases and is not a crystalline silica. It is bound in with alumina, not creating mullite or other different phases, and is not considered to be a quartz or a cristobalite. That's why our SDS says it's completely safe. It's even safe enough to eat, I think, but I don't know if I would go around eating it. Mold wash is another big form of crystalline silica. Some mold washes do contain the crystalline silica, and it's something that you got to look at. Mold parting powder is a powder that's used to part very large molds. Basically, mold wash and mold parting agent we found out about from one of our customers. They had converted to us. A couple of months in, they wanted to run another Pell test to basically have the data to show OSHA if they walked in that they met the Pell, because they had converted to ceramic media. When they ran that test, they found out they failed in their mold line. At that point, they contacted us. We asked them to send us samples of all the different materials they were using in there, and they also contacted their other vendors. What we found then was that the mold wash contained crystalline silica and the mold parting powder did. What we did they could find another mold wash that did not contain crystalline silica rather easily, so that was easy. The mold parting powder was a little more difficult since it's a more specialized market. So what we did is we actually sent them some of our flowers that are made from our materials that do not contain any crystalline silica and had them try that. They found that works very well. They're very happy with it, and they have converted over to using that for their parting agent. The other areas that contain crystalline silica are your refractors, your furnace lining, your ladle backing sand, your ladle liners, your clays, random material, and mud. You know, as all we've talked about, there are other options out for each one of those that do not contain crystalline silica. For the ladle backing sand, we've actually created our own answer for that. We've created our own ladle backing media that does not contain any crystalline silica, and we are seeing people that are using it, they're getting double to triple life out of their ladle liner. And that's mainly to do with the material goes in and it holds the ladle liner better because the material rolls in better and to support it, and also it does a better job of conveying the heat and that for the steel liner. I should say insulating it from the steel liner on the outside. Again, if you guys want to talk about any of those things, please reach out. We'd love to send you some information on them. That's all I have. I want to thank you all for attending and listening to me talk about ceramic media, and I want to open this up for questions.
Thank you, Ray, and thank you for everyone's attention. Now, if you'll please ask any questions that you might have in the portal, and we'll give you just a couple of seconds to submit those. While you're submitting those, we'd just like to let you know that we do provide technical support for all of our products, including ceramic casting media. Also, be sure to register for Part 2, Understanding the Full Benefits of Switching to an Alternative Non-Crystalline Silica Casting Media, which happens next Thursday, the 19th. Now for a few questions. Let's see. What is the product's expected life cycle?
That's a very good question. A lot of people worry about when we talk about doing a conversion, how long can they run this over and over continuously? The best way I have to answer that is it's almost infinite. And the best way to convey that is, Claude Krauss, my colleague, did a webinar on the green sand data that AFS had paid to run with ceramic media in December. And Western Michigan did the testing on it. When they were doing the standard silica wear test, they showed zero breakdown on the CARBO materials. So they had to create a whole new wear test to get some kind of wear to be able to show it work breaking down. That fact alone tells me that this stuff just doesn't wear out. It's so hard and everything. So, my words to everybody that talks about it is you're not going to see it. You're going to basically lose it through your system before you'll see the wear, which you don't lose much.
Okay. What is the biggest misconception with making the switch to ceramic?
Usually it's cost. People feel like it's so much money to convert. The number one comment I get is, oh my gosh, it's so expensive. Well, that's part of why we're going to do the ROI talk in next week, because I can show you a cost breakdown and show you a payback of under a year. All of our clients have seen it. Between the reduction in resin or clay, the increase in surface finish, and the so little you buy of the CARBO or the ceramic media compared to your silica sand, the payoff is generally less than a year. We've seen people as low as 6 months. So, what's interesting to me with that is after you get through that ROI cycle, then basically you're making money on the conversion. So that's why all of our clients say they wish they would have done it sooner. Great question.
Okay, we have time for one more. Let's see. Do I need to do any tooling rework for the dimensional changes from silica to ceramic media?
That's another interesting question. I know I hear that question a lot. People are considering it. They feel like they're going to have to, especially when we talk about the thermal expansion being so much different than silica. The answer is no, you don't. And a lot of that reason is they do a lot of additives and everything to compensate for that thermal expansion with silica. And basically with our materials, you don't need those because you don't see that thermal expansion change at all throughout the process of it. So, we have yet to see somebody have to do a tooling rework due to the thermal expansion differences of the material.
Okay, thank you, Ray. That's all the time we have for today. If you submitted a question and we weren't able to get to it, we will definitely reach back out to you with an answer. Like we mentioned before, the webinar was recorded, so you can play back at your convenience. And please contact us directly if you have any questions. Thanks again, and have a great day.